very happy to introduce our latest series of videos. We filmed these in an IATF 16949 certified organisation, a Tier 1 supplier involved in the remanufacturing of used diesel particulate filters. With an ever-increasing focus on the environment and sustainability, remanufacturing in the automotive sector is continuing to increase. And for these remanufactured diesel particulate filters, it's essential that they are fully compliant with the stringent emissions legislation. The videos that you're going to see will show extracts of simulated IATF 16949 audits focused on the organisation's remanufacturing processes. So watch the videos and see if the auditor is undertaking the audits effectively. As always, we really welcome and value any feedback and comments, so please feel free to drop any comments under the videos.
So earlier we saw the performance verification.
Yeah.
I want to now move on to the inspection process in your control plan.
Okay, yeah.
And this is a critical step in your process. Can you take me through what are you inspecting then when you check a filter?
Normally I'll do a physical inspection because I'll get, the machine has done much of the interior. Yeah. It has got photos, it has taken photo from the inlet and also photos from the outlet, and it also has taken an IR which goes past the smoke if there is any smoke or anything.
Right, okay.
So I'll get those images onto the screen and I'll be able to verify whether they are okay. For me, the main thing is to do a final inspection is to go through the filter again. It has been checked by other areas, but because this is the final stage, I'll start by checking whether the brackets have got any damage, whether they have been missed, and whether it has got any can damage, and whether we have got any ceramic damage from both sides, the inlet and the outlet. And then from there, we've got a gauge here, which we use to measure whether the filter has moved. Sorry. Whether there has been any movement from substrate. So I'll measure that. The green shows me that it's good to go.
Oh, okay, so that's the depth.
That's the depth. So if it was more than that, it would have been a problem filter.
Yeah.
Yep. So from there...
And you do that both sides?
No, we do only one side because this is what goes in the vehicle.
Oh, okay, okay.
From the pressure, this is the only area that can be pushed to come onto the other area.
So it's that one is the critical depth, which actually matches the control plan.
Yeah.
Okay.
Yeah. So, and then from there, if I'm happy with all the inspections of the filter, I'll compare the number which we call CX number.
CX, yeah.
Yep. And the number which is the CAN number, the customer number, which is 2137598. I'll compare that with whatever we have got on the CAN. That number there.
Yeah, here it is, yeah.
So if I'm happy with that number, it's the same number. Then what I'll do is, on my screen, we normally use a system called Green Tree.
Green Tree.
Green Tree, yeah. And on the left, we call it MLC. It's the one that takes the images. And I'll show you.
Okay, from the previous step, the performance verification.
All the stages of the machine will be on this screen and this screen as well.
And would this automatically tell you if there was a problem?
It will.
How does it show that?
It will show on the screen here and on the images. It will show, I'll be able to detect, if there is a problem, I'll be able to see the images. If the images are too black, too dark, I'll know that's a problem, there is a problem with the filter. But there is two other ways. I've got a wire here, which I will also be able to pin the filter from the inlet. I'll pin the filter to know whether the filter has got a problem.
Okay,
but the screen will show me before I get to that.
Yeah. And if you find the filter has a problem, what happens to that filter?
We normally fail the filter for the problem it has. We got the failed ones go in here. So we've got some which have failed due to either it has got ceramic damage or it has got catalyst test, or it has got airflow fail.
Yeah.
So we normally fail it, and we got on the screen we got a work Microsoft Excel, whereby we input all those details and we print a label which will accompany that filter.
So they know the reason
They
for
know the
rejection.
reason why it has failed. Yeah.
Okay. What happens if we find that we have a problem with the weld on the bracket?
If there is a problem with the weld, what I'll do is I'll quarantine the filter, send it back to quarantine area.
Yeah.
We've got a quarantine area whereby the filter will be taken to the welding bay.
Yeah, and we're going to have a look at that next.
Yeah.
So, okay.
Yeah.
No, thank you very much for that explanation.
Most welcome.
What work instructions do you have that explain what you've just explained to me?
We follow a system called SOP, Standard Operation
SOP.
Procedure, which is standard in this place.
Yeah.
Which
so this
shows,
is where, yeah, GT and FI.
Yeah. FI is final inspection.
Yeah.
And it shows me all the gadgets that I should have.
See
to
the
do
depth
inspection.
check, for
The depth
example.
check, yeah.
Yeah.
And then I've got the gouge check, how big the area of the gouge is. And this shows me the screen of what tools I should have on my...
On your workstation.
Yeah.
Yeah.
So,
And can I take the number off the gauge that you did the depth check?
Yep.
Can I just record the number?
We call it VE,
VE, yeah.
15-2.
F1.
F1. F1
Right.
stands for finals.
And
final
this is
inspection.
valid until February
2025.
2025.
Yeah.
So I'll check that in the calibration process later
Yeah.
then.
Yeah.
Okay, and the revision level, can I just take the revision level off the work instruction? When was this issued?
This was issued,
26th of the 5th,
Yeah.
2023, revision 1.6.
Yep.
Yeah,
They get reviewed from time to time.
yeah,
If there are any changes,
yeah.
we get them reviewed.
Okay,
By
I'll follow
quality.
up on that later.
Yeah. So it takes me through what I should have. So
Yeah.
by the time when I start my shift, should check whether I have got all those tools to enable me to do the job.
Yeah,
Yeah, without any one of them, I should inform my team leader or supervisor
Yeah.
that I'm missing one of the gadgets, so I can be able to perform
Yeah.
and be able to carry
and
out
in
the
terms
duty.
of lighting in the area, is there any particular requirement about the level of lighting?
Yes, there is. For this area, because I'll need to see the filter in depth, I've got this light whereby I can tweak it the way to allow me to see the filter and to be able to read
To
everything.
read that, okay.
Yeah, I can tweak it. If it will be that, if it's too much on my face, I'll bring it down so that I can
So
be
we
able
can
to see
see the numbers.
Yeah.
Yeah. Excellent. Thank you very much for your explanation
Most
there.
welcome, sir.
In this video, the auditor is auditing the inspection process, which, as well as visual inspection, includes the operator verifying conformance by interpreting the data collected during the previous process, namely performance verification. In auditing this process, it gives the auditor the opportunity to question the operator on the inspection standards related to visual inspection acceptance criteria. For example, the acceptable levels of ceramic or bracket damage. A key input into the process is that data from the performance verification process needs to be interpreted by the operator. The auditor should follow the audit trail to the competency criteria and associated records of competency for the people performing this task. This could include, for example, attribute measurement system analysis to verify the capability of the people making the visual inspection decisions, especially as this operation is defined as a special characteristic in the control plan. The auditor, using the control plan, questioned the operator on the things that are checked during the inspection and what action is taken if any non-conforming product is identified. The auditor, once the operator had explained the process, referred back to the work instruction to verify the information that had been provided by the operator matches the documented information. This also gives the opportunity to follow audit trails on the calibration of any equipment used within the process. For example, in the video, we saw the operator using a go-no-go gauge. And also they have the opportunity to verify the documentation control over the work instructions that are used within the process. Where visual inspection is performed, one of the potential variables is the lighting within the inspection area. The auditor should follow the audit trails to see if the lux level has been specified, and if so, how this is monitored for compliance with the relevant specifications. Finally, one of the important things at this stage of the process is product traceability, because the etch that was put on earlier within the process provides a unique traceability to see the filter through the remanufacturing process. So let's summarize. A key part of any audit is the auditor competency to enable them to interact with personnel at all levels of the organization, including the operators working within the manufacturing and the inspection process. In this audit, the auditor's style put the auditee at ease, encouraging the auditee to explain how the process works, and then, after the evidence was collected, the auditor referred back to the work instruction for the process. In any audit of manufacturing, it's essential that auditors make use of the control plan, verifying the controls implemented and then linking back to the level of risk in the PFMEA, in particular if there are any special characteristics.